Okay, so yeah, let me know if you have any questions from the differentiation worksheet or from any recent papers. In the first half, we will do those practice questions today, and then we start integration after that. All right, so let's begin with this. So first of all, Hazem is saying question number 9. Let's start with that. Question number 9 from the worksheet. Okay, let's have a look at this. Okay, I think there were a couple of questions that you guys asked in the last class as well. I'm forgetting what those question numbers were. So if you still have those problems, please write them in the chat box again, so we can just discuss those questions today as well. All right, question number 9 from the worksheet. Let's try this. It says a wire 80 centimeters long is cut into 2 pieces. One piece is bent to form a square of side x centimeters, and the other piece is bent to form a circle of radius r centimeters. You can see the diagram. The total area of the square and the circle is a centimeter square, so that the area equals this. Okay. Now, let's see the information that we're given in the question. So it says the wire is 80 centimeters long. So the total length of the wire, that's 80 centimeters. It's cut into 2 pieces. And from those 2 pieces, you have 2 shapes made. One is a square that has side x centimeters. This is the perimeter of the square. This is made from the wire. And this is the perimeter of the perimeter of the circle. This is also made from the wire. The total length of all of these sides, that is 80 centimeters. Okay, so what we can do is we can make an equation like this, that the sum of all of these sides, the 4 sides of the square and the circumference of the circle, the sum of all of these should be equal to 80, right? Because these sides are all made using this 80 centimeter long wire. Let's make an equation using that. So what's the perimeter of the square? One side is x, x plus x plus x plus x, that's 4 times x. So 4x plus the perimeter of the circle, the circumference of the circle, that's 2 pi r. 4x plus 2 pi r, this should equal 80. That is one equation that we have. We can simplify this and write it like this: 2x plus pi r equals 40 by dividing the whole equation by 2. That's one equation that we have. Now what we need to do is we need to find the total area of the square and the circle. It says the total area of the square and the circle is given by A. We need to show that A equals this thing. Now, let's write down the area of the square as well. What would be the area of the square? Area of the square is going to be x squared, right? Plus the area of the circle. What's that? That's pi r squared. This is the value of A, the total area of the circle and the square, right? That's the value of A. Now, what we need to prove is, we need to prove that A equals this thing. We are getting A equal to this. Now, what's the difference? How do you go from this form to this form? That's what we need to think about. Now, in the area that we have calculated, in the area that we have found, we have 2 unknowns. We have x and we have r. We have 2 variables, right? And in the form that they have given in the question, they only have x. They don't have any r there. So we need to somehow eliminate r from this form. How can you do that? This is where this first equation that we have formed, that comes in. What we can do is we can make r the subject from that equation and put that in the second equation, in the second form. Let's make r the subject from the first equation. So we can say this is pi r equals 40 minus 2x, and then r equals 40 minus 2x whole divided by pi. And now we can just input this thing in that other equation. This becomes a equal to x squared plus pi r squared. So it becomes pi into 40 minus 2x divided by pi whole squared. right? That's what we end up getting from this. Now let's simplify everything. We have x squared plus pi into 40 minus 2x whole squared. Let's expand this, a minus b whole squared. What does this become? 40 squared, that's going to be 1600, minus 2 into 40 into 2x, that's 160x, plus 2x whole squared, that's going to be 4x squared. That's what we have in the numerator. In the denominator, we have pi squared. So you have pi squared in the denominator. Now, 1 power of pi gets cancelled with the pi that you have in the numerator, this pi and this pi squared. They get cancelled. What are we left with? X squared plus 1600 minus 160x plus 4x squared divided by pi. This is what area equals. Now, again, let's look at what we want at the end. So now we have everything in terms of x only, but it's not the exact form that they have asked us to prove. Now, notice the difference. We have two terms. We have one x squared term separate, and then we have a fraction here. In the form that they want, they only have a single fraction. So what we can do is we can take LCM here and make it a single fraction. Let's take LCM. The LCM is pi. So pi gets multiplied with x squared, and that gives us pi x squared plus 1600 minus 160x plus 4x squared whole divided by pi. Now again, compare with what you want at the end. So you have minus 160x, you have minus 160x here. You need 1600, you have 1600 here. Then you have pi plus 4 whole multiplied by x squared. We have two x squared terms. All we need to do is take x squared common from these two terms. Look at these two terms. Take x squared common from them and write the coefficient of x squared separate. That's going to become pi plus 4 whole multiplied by x squared minus 160x plus 1600. This is what we needed. Area equals this whole thing, and that's what we needed to prove in the first part. Okay, area equals this thing. That's the first part. That's what we had to prove. Make sense? Any problem with this?
Sir, why did you write out the first equation?
Sorry, how did we write the first equation?
Yeah, where did we get that from?
Okay. It says the total length of the wire is 80 centimeters, right? Total
Yes.
length of the wire, that is 80 centimeters. Now, we have made two shapes using that wire. One is this shape, a square, and the other is this circle. The perimeter of each of these two shapes is basically made from that wire. So what's the perimeter of the square? 4 times x. What's the perimeter of the circle? 2 pi r. The sum of both of them should be equal to 80. Right?
Yes, sir. Okay, thank you, sir.
No problem. That's the first part. Now, what about the second part? It says, given that x and r can vary, find the value of x for which a has a stationary value. Stationary value means it could either be a maximum value or a minimum value, any of them. Since it's a stationary value, we can say the derivative should be equal to 0. So all we need to do now is find the derivative of this expression and put that equal to 0, right? Now, what's a equal to? A is equal to pi plus 4 whole multiplied by x squared minus 160 times x plus 1600 divided by pi. Now, another way of writing this could be that we write 1 over pi separately. That will simplify things for us. 1 over pi into this whole thing. So we write pi separately on the side. So that this is a constant that's multiplying. When we find the derivative of this constant is going to remain as it is, right? It will simplify our differentiation process. So when we differentiate something, the constant outside remains as it is, right? So now let's find the derivative. Now, what are the variables? If you had y equal to something in terms of x, you would say the derivative is dy over dx. Now here, instead of y, you've got a, right? So when you find the derivative here, you would say this is dA over dx. These are the variables. The subject is a, so that's dA. And the variable that you have on the right side, that's x. So that's dA over dx, derivative of a with respect to x. What does that turn out to be? 1 over pi remains as it is, the constant multiplying outside, that will not change. And then you find the derivative of this thing. Pi plus 4 is a constant multiplying with x squared, that remains as it is. Multiply by the power. Subtract 1 from the power, x power 2, it becomes 2 minus power x power 1. Then you have minus 160x. What's the derivative of minus 160x? It's just minus 160. And the derivative of 1600 is 0. This is what we end up getting. Now we can just put this equal to 0, right? Why are we doing this? Because we're looking for the value of x at which a has a stationary value. We don't always put the derivative equal to 0. We are only putting this equal to 0 because we're looking for a stationary value. And that's why we are putting this equal to 0 like this. Okay, so that's what we get. 0 equals 1 over pi multiplied by pi plus 4 into 2 times x. Let's actually just multiply this inside. It's going to become 2 pi x plus 8 times x minus 160. Now this pi goes to the other side, gets multiplied by 0, and it gets eliminated. What are we left with? 2 pi x plus 8x minus 160. That equals 0. In fact, we can just leave it in this form, 2 pi plus 8 times x, because we're looking for the value of x. That equals 160, and x equals 160 divided by 2 pi plus 8. That's the value of x at which a would have a stationary value. Now, do they ask us for an exact value? No. So if you wanted an exact value, you could leave it like this. It could be simplified to 80 over pi plus 4 as well. But they've not specified that they need an exact answer, so you can write down this value in decimals as well. You can see what this turns out to be. 80 over pi plus 4, what's this? 11.202. 11.2, that's your final result. This is what we're looking for. This is the value of x at which a has a stationary value. Now, if they asked you to find that stationary value of a as well, you would just input this value of x in this function, and you get that corresponding value for a as well. But they haven't asked for that in this question, so we'll just leave it like this. X equals 11.2, that's what we were looking for.
Sir,
Yes.
sir, you took pi to the left side. Won't we divide it with the equation, with the thing which is being multiplied inside the bracket? 1 over pi.
We could do that, but
Yeah.
isn't it simpler to just multiply this on the left side and it becomes
Okay,
0?
sir.
Why make things more complicated? You can do that if you want. Eventually, you go to the other side, becomes 0. In any case, right? Okay, so that's the second part of question number 9. Any other questions from the worksheet? Any other questions? Question number 19. There was this question as well. How many of you attempted this question? I asked you to attempt the second part of this question. Can I raise your hands if you attempted this question or you just forgot? Please raise your hand if you attempted this question. I think I asked you to do this in the last class. No one? Okay. That's a bit disappointing again. But let's have a look at this question for now. Question number 19, we'll get back to that question in a moment. Question number 19. Let's try this. All right, so the diagram shows an open rectangular tank of height h meters covered with a lid. This is the height h meters. It's a tank that's covered with this lid on top, right? The base of the tank has sides of length x meters and half x meters, and the lid is a rectangle with sides of length 5/6 meters and 4/5 times x meters. All of that is shown on the diagram as well. When full, the tank holds 4-meter cube of water. Okay, now that's an important piece of information. When full, the tank holds 4-meter cube of water. That means the volume of the tank is 4-meter cube. The space in the tank, that is 4-meter cube. Okay, so you can make one equation using that information. Then it says the material from which the tank is made is of negligible thickness. That basically means the thickness of this part, the lid, for instance, and also the lid, the thickness of the sides of this container, that can be ignored. All right, so it's negligible thickness. The external surface area of the tank together with the area of the top of the lid is a meter squared. Express h in terms of x and hence show that a equals 3/2x squared plus 24/x. Okay, first of all, we need to express h in terms of x and then also show that area equals this thing. What's the area? Area is basically the external surface area of the tank together with the area of the top of the lid. That is represented by this letter A. Okay, now let's start with this. Express h in terms of x. Now, we saw this information here in the question. It says the volume of water that this container can hold is 4-meter cube. All right, so the total volume of this container is going to be 4-meter cube. How do you find volume of a cuboid like this? Just multiply all sides, x into half x into h. That's the volume of the container. What's the volume equal to? Volume is equal to 4. So we can say x into half x into h, this equals 4. This is an equation that we've got. We need to find h in terms of x. So we need to make h the subject here. How can we do that? This becomes, so you can take 2 to the other side. That becomes 8. And then this is x, that becomes x squared. That goes to the other side, gets divided. And you have h equals 8/x squared. That's one thing that you have to do. You've represented h in terms of x. Okay. That's the first thing we need to do here. H in terms of x. Now we need to show that the area of the external area of the tank, external surface area of the tank with the area of the top of the lid is a meter squared. Now, what's the external surface area of this tank? Let's have a look at this diagram. How many faces do we have for this tank? We have 4 sides, right, left, front, back. That's the 4 sides, the faces on the sides. Then you have one face that is at the bottom. So there are 5 faces of the tank, all right? It's an open rectangular tank, so there is no surface on top. There's no face on top. Even if there was, we would not count that as external surface area because there's a lid on top. So the lid is the external thing that we will count instead. So we have 5 faces of the rectangular tank, first of all. Okay, so let's mark those 5 faces. We have one face here on the side. There will be one on the other side here, like this, on the left side. Okay, then there's one face that is at the bottom. This will be the base of the rectangle. This is another face, the base of the rectangle. And then there's a front surface. front face, this face, the green one. And similarly, there's a face on the other side of this, the back face. That's going to be this one. These are the 5 faces that we're talking about. Okay. So there's this green surface, green face in front. There's one right opposite to it on the back side. So there are 2 yellow faces, 2 green faces, and then there's one bottom face. All right. These are the 5 faces that we have. Now, let's add the area of these 5 faces first of all. So what does area equal?
Sir,
Yes.
sir, what about lid? The
Yeah,
top.
we'll add lid. Yeah, we'll add the lid as well. So this is the lid as well. We have to consider the area of the top of the lid as well. So we will add that to this area as well. Let's consider the container first, and then we'll talk about the lid afterwards. So there's a bottom surface. What's the area of this rectangle at the bottom? X into half x, right? That's one thing, x into half x. Then yellow faces, the one on the right and the one on the left. What's the area of these 2 faces? Half x into h. That's the area of one of these faces. Half x into h, but there are 2 faces like this, so we can multiply this by 2. Plus the green face, you have x as this side and the vertical side is h, so x times h. That's the green face. But then there are 2 green faces, so we multiply this by 2 as well. These are the faces of that container. Okay. This is the yellow face. We multiply that by 2. This is the green face. We multiply this by 2 as well. This is the bottom surface. And now what about the top of the lid, the upper part of the lid? There's 5 over 4x one side, and the other side is 4 over 5 times x. What's the area of the top of the lid? That's all of this region. Just multiply those 2 as well. That gives you 4 over 5 times x into 5 over 4 times x. That's the area of the top of the lid. Now you just add all of these areas up and see what that gives you. Okay, so area equals half x squared plus this 2 and this 2 get cancelled, and we have x times h plus 2x times h, and then 5 and 5 get cancelled, 4 and 4 get cancelled, and we have x squared here. Now let's simplify this. 1 over 2x squared and x squared, that becomes 3 over 2x squared plus 3xh. That is what the area turns out to be. Okay, so that's what we've got until this point. Now let's look at what they have asked us to prove. This is the area that we're getting in terms of x and h. They have asked us to prove that the area equals this, 3 over 2x squared plus 24 over x. Now, in this form, they do not have any x. They do not have any h there. So what can we do? We can eliminate h from this by using what we already proved above, that h equals 8 over x squared. Right? Let's use that to eliminate h from this. So instead of h, just input at 8 over x squared and see what that gives you. 3 over 2x squared plus 3x into 8 over x squared. Now let's simplify this. Area equals 3 over 2x squared plus 24 over x. And that is what we wanted to prove, that area equals 3 over 2x squared plus 24 over x. That's the first part. We have proved that.
Sir,
Yes.
sir, to find surface area, can't we use the formula length into height, base into height, and then length into height, basically?
That will be if it was a proper cuboid like this with closed surfaces, with a closed top as well. If it was like this, a cuboid with 6 faces in total. you would have one face on the left, one on the right, one at the bottom, one on top, one in front, and one at the back. You'll have 6 faces. You could do it something like this 2 times length into breadth plus length into height plus breadth into height. That will be for that standard cuboid. But the problem here is the top, there's no top surface, right? There's no top surface, there's no top face of the container that we have here. And instead of that, we have another lid. So it's not going to be the same as this. I generally do not recommend using formulas for either perimeter of 2D shapes or surface area of 3D shapes. It's mostly easier and safer to just find the individual areas of all the faces that you have and then add them up together, because often the shapes that you get, they're not very standard. So to find the surface area, the best way to do that is just find the area of each of the shapes that you have, each of the faces that you have, and then add them up together. Similarly, in 2D figures, if you want to find the perimeter, do not use any standard formulas. Just find the length of each side and then add them up together. Okay, that's going to be a better way of doing this rather than remembering the formulas, because the formulas do not always work, because mostly the shapes are not standard. They just change something and then you are stuck because the formula cannot be used there anymore. Make sense?
Sir, can you please tell how did you made this equation for A?
Which equation?
Sir, this A is equals to x into 1 over 2x. Yes, this.
We have just found all the areas separately. So what's the base? This is a rectangle at the base of the container. What's the area of this rectangle? X into half x, right? So that's one face. What's the area of the face on the right side, the yellow face? It's a rectangle with one side h and another side half x. Just multiply those two. And then since there's another yellow face on the left side as well, this one, you multiply that by 2. Then you have a green face, the one that you see in front. What's the area of this rectangle, the green rectangle? X times h. There'll be another rectangle at the back side as well. So we multiply this by 2 to get 2xh. So that's what we're doing. X into half x, this is the area of the bottom face. This is the area of the yellow face. Multiply that by 2 because there are 2 yellow faces. XH is the area of the green face. Multiply that by 2 because there are 2 green faces. And this is the lid.
Okay, sir. Thank you, sir. Sir, actually, I was using the other formula when I solved the question, so I was getting the wrong answer. The
Yeah, you
surface
can't
area.
use you should not be using surface area formulas generally. Just find the areas of the faces and add them up together. Areas of all the faces individually, add them up together, because mostly the shapes that you get, they're not going to be standard. There's going to be some variation and the formula is not going to work. Okay, that's what happens in most cases. So find areas of individual faces, then add them up together to find the surface area. All right.
Yes, sir.
Let's look at the second part now. It says, given that x can vary, find the value of x for which a is a minimum, showing clearly that a is a minimum and not a maximum. Now, how do you do that? You have the area formula, area function, area equals 3 over 2 times x squared plus 24 over x. We can write it like this, 24 x raised to power minus 1, right? Now we can apply the power rule on this. What's dA over dx? Derivative of a with respect to x. 3 over 2 remains as it is, multiplied by 2, subtract 1 from the power. That becomes x plus 24 into minus 1 into x raised to power minus 2. That's the derivative. Let's simplify this. That gives us 3x minus 24 over x squared. Now put this equal to 0. Why? Because we're looking for the value of x for which a is a minimum. So we put this equal to 0. And now we solve this equation. How do you solve this equation? We have a fraction here. Okay, let me do it this way. 24 over x squared, that equals 3x. Multiply x squared on this side. That's going to give you 24 equals 3x cubed. and then x cube equals 8. Take cube root in both sides, that gives you x equals 2. So this is a value of x for which a has a stationary value. Now we do not know for sure whether this value is a maximum or a minimum. How do you prove if some value is a maximum or a minimum? In this case, it shows, they ask you that show clearly that a is a minimum and not a maximum. How do you prove that? You can find the second derivative, right? That's how you figure out if something is a maximum or a minimum. You have the first derivative already. What's the first derivative? The first derivative is 3x minus 24 x raised to power minus 2. That's the first derivative. Let's differentiate it again to find the second derivative. That's d square a over dx squared. That equals 3 minus 24 into the power, that's minus 2. Subtract 1 from the power. This is what we get. Simplify this. That gives you 3 plus 48 over x cubed. Now, is this positive or negative? How do we know that? We can't, we don't know that for sure because this is x cubed. So how do you figure that out? You put this value of x here now. To see if it turns out to be something positive or negative, you put x equal to 2 here. And the second derivative turns out to be d square a over dx square. That equals 3 plus 48 over 2 cube. That's 3 plus 6. And that's 9. It's a positive value. Since it's a positive value, we say we have a minimum value of a when x equals 2. And that is what we were looking for. We were looking for the value of x at which x is a minimum. We found the value of x, that's x equals 2, and we've proved that that's a minimum value because the second derivative is positive. If the second derivative is positive, the value of a that we have is going to be a minimum rather than a maximum. Is that okay?
Yes, sir.
All right, so that was question number 19 from the worksheet. Any other problems from the worksheet? Any other problems, anyone? No other problems? Okay, let's do this last question then on differentiation, then we start integration after that. So this was one question that I asked you to do from the worksheet. It was not actually from the worksheet, it was a separate question that I asked you to do. Let's try this. It says a curve is defined for x greater than 0 and is such that dy over dx equals this. The point P lies on the curve. What we need to do is we need to show that the gradient of the curve has a minimum value when x equals 2 and state this minimum value. Now, how do we do this? Any idea? How do we show that the gradient of the curve has a minimum value when x equals 2? Any idea? How do we start?
Sir, we can take double derivative of the equation and then put the value x equals 2 into it.
We also have to figure out if this is even a stationary value at all.
Okay.
Right? How do we know it's a stationary value? So we also need to prove that. So we can't assume it's a stationary value. How do you prove that this is a stationary value? X equals 2. Okay, now think about this. This statement is slightly confusing. What are they asking for? They're asking for the minimum value of what? Minimum value of the gradient of the curve. They're not asking for the minimum value of the actual function. They're asking for the minimum value of the gradient of the curve. All right. Now, what does that mean? Now, curve is going to be something in terms of y, right? Y equals some expression. That's going to be the equation of the curve, right? If we had to find the minimum value of the curve, what would you do for that? You would find the derivative. We already have the derivative. And we would put that derivative equal to 0. So if you had to find the minimum value of the curve, you would say put dy over dx equal to 0. So that will be x plus 4 over x square equal to 0. You'll find the value of x from this and see what that turns out to be. If you had to find the minimum value of the curve, that's what you would do in that case. But we're not asked for the minimum value of the curve here. They're basically saying the gradient of the curve. The gradient of the curve that has a minimum value when x equals 2. You need to show this. Now, what's the gradient of the curve? dy over dx. dy over dx is x plus 4 over x square. What does dy over dx represent? Dy over dx basically represents the gradient of the curve at every point. So what we can say is this is the gradient function that we're talking about. Now, in order to simplify things, what we can do is we can say this is the gradient of the curve, right? This is the gradient of the curve. We can represent it by a new letter, let's say g of x, right? So just in function notation, we can say g of x equals x plus 4 over x squared. What does that mean? G of x is what we're saying is the gradient function. This is the gradient of the curve. Dy over dx, it basically represents the gradient of the curve. So this is the gradient of the curve, x plus 4 over x squared. Now what we need to do is we need to find the minimum value of this gradient. We need to show that the minimum value of this gradient occurs when x equals 2. Now, how do you do that? Forget about what you had originally, that this was a derivative of some function. Treat this as a new function. This is the gradient. We need to find the minimum value of this gradient. We need to find the minimum value of this function. Treat this as a new function. How do you find minimum value of any function? You find the derivative of that, put that equal to 0. And that's what we're going to do here. This is the function that we're talking about. This is the gradient of the curve. We need to find minimum value of this. We differentiate it. Now for that, we first need to write it in power form. It becomes x plus 4x raised to power minus 2. We find the derivative of this, g dash of x, g prime of x. The derivative of x is 1. The derivative of 4x raised to power minus 2, that's going to be 4 into minus 2 into x raised to power minus 3. And that turns out to be 1 minus 8 over x cubed. This is g prime of x. This is the derivative of the gradient. Now, since we're looking for the minimum value of this gradient, we put this first derivative of the gradient. This is the first derivative of the gradient. We put this equal to 0. Why do we do that? Because we're looking for the minimum value of the gradient. That is why we put this derivative equal to 0. Now, when we do that, what do we get from that? 1 minus 8x cubed, 1 minus 8 over x cubed. That equals 0. We can write this as 8 over x cubed equal to 1. 8 equals x cubed, and the value of x turns out to be 2. This is the value of x at which this gradient has a stationary value. Now we need to prove that this is a minimum value and not a maximum value. How do you prove that? You find the second derivative. The first derivative was 1 minus 8x raised to the power minus 3. We differentiated once more. That gives us g double prime of x. That's minus 8 into minus 3 into x raised to the power minus 4. And that's 24 over x raised to the power 4. Now put that value of x here, put x equal to 2. What does that give us? The second derivative of the gradient turns out to be 24 over 2 raised to the power 4, which is 1.5. It's a positive value. That means we have a minimum point when x equals 2. So that's the first thing we had to do. We had to prove that the gradient of the curve has the minimum value when x equals 2. We have done that. All right. Now it says, state this minimum value. What's that minimum value of gradient that we're talking about? What is that minimum value? You have the gradient function now. What was the gradient function? The gradient function was x plus 4 over x squared. This was the gradient function. Just put that value of x back here. X plus 4 over x squared, and that gives you, when you input x equal to 2 here, you get g of x equal to 2 plus 4 over 2 squared. That's 2 plus 1, and that's 3. This is the minimum value of gradient. So minimum value of gradient occurs when x equals 2. And what is that minimum value? That value is 3. And that's what we had to prove. That's what we had to find out in this case. Make sense? Now, let me repeat. They asked us for the minimum value of the gradient. All right, minimum value of the gradient, not the minimum value of the actual function, not the minimum value of the curve. They're asking for the minimum value of the gradient. So how do you find gradient of a curve? Using derivative. So this derivative basically represents the gradient of the curve. We treat this as a new function. We say this is the gradient of the curve. How do you find the turning point of this gradient now? The minimum value of this gradient now? Find the derivative of this, put that equal to 0, you get the value of x. Find the second derivative. Since that's positive, it's a minimum value. How do you find that minimum value now? Put that put that value of x, that's 2, back in the equation. And that gives you that minimum value of the gradient as well. And that is what we were looking for here. Any questions on this? Is this process clear to everyone? Now, if you look at the marking schemes, of such questions, they will be doing something very confusing like this. So they'll basically, for this, they'll do something like this. They'll put the second derivative equal to 0. Generally, we put the first derivative equal to 0, right? So in the marking scheme, they'll write something like this. Put the second derivative equal to 0. What they're actually doing is they're basically finding the first derivative of the gradient and putting that equal to 0. Right? So the marking scheme is kind of confusing for such questions. So that's why people get confused with this. And then they would be finding the third derivative, d cubed y over dx cubed, and figuring out whether that's positive or negative. In this case, it's positive. That's why they'll say it's a minimum value. What they're actually trying to do is they're treating this gradient function. They're treating this as a gradient function, finding the first derivative of that. The first derivative of that is going to be this. You put that equal to 0. For the original function, that will be the second derivative. But we're not considering the original function at all here. We're saying this is the gradient function. We're just thinking of this now. Find the first derivative, put that equal to 0. That gives you the value of x. And then find the second derivative of this gradient function. And that is going to give you a positive value. That's why it's a minimum value. Okay, so the marking scheme for such problems is slightly confusing. I'll upload the integration worksheet today as well. You can have a look at the marking scheme. I would suggest that you approach it this way, and that's going to be the same method that you've been using before. There's nothing different. The only thing that you need to realize is that dy over dx is basically the gradient of the curve. And then you just treat that as a new function. All right, yes, Abdullah.
No, sir, it's cleared.
Okay. All right, so that's it. That's it on differentiation. That's all that we needed to do. I think we've done enough practice. Now I should be able to do all questions from recent papers as well. Now we're starting our next topic, which is integration.